Today, we're diving into a really cool new way of thinking about AI, inspired by, of all things, our own brains. It's a project called Memento, and it's all about a simple but powerful idea: teaching AI to remember its experiences, instead of constantly having to relearn everything from scratch. So let's just get right to the heart of the problem with this question. We have these incredibly smart AI agents, right? But they have this one massive blind spot. When it's time to learn from a mistake or a new experience, why does it feel like we have to give them a complete brain transplant just to update their knowledge? It's a huge bottleneck, and it's been holding back what these agents are truly capable of. So, to really get why Memento is such a big deal, we first need to understand this fundamental dilemma that AI developers have been wrestling with for a while now. Okay, so traditionally, you've had two main options, and frankly, neither is great. On one side, you've got parameter tuning. Think of this as sending the AI back to college every time it needs to learn one new thing. It's incredibly expensive, takes forever, and it has this nasty side effect called catastrophic forgetting, where learning a new skill can literally make it forget an old one. Then, on the other side, you've got fixed workflows. These are super rigid. They're like a recipe that works perfectly for one dish. But the second you ask it to make something else, it just completely falls apart. So you're stuck between a rock and a hard place. One method is too expensive, and the other's too fragile. And that leads us right to the million-dollar question that the Memento researchers posed. How do you break out of that trap? How can you build an agent that learns on the fly, continuously, without that insane, prohibitive cost, that digital brain surgery, every single time? And this is where Memento's solution is just so elegant. It carves out a third path, one that avoids the old problems entirely: learning without retraining. The big idea here is so simple, it's brilliant. Stop trying to constantly rewire the AI's core programming. Instead, just give it a perfect external memory of everything it's ever done: the good, the bad, and the ugly. Now, this approach isn't just some wild idea they came up with. It's actually grounded in a real psychological concept called case-based reasoning, or CBR, and it's something you and I do constantly without even thinking about it. When you run into a new problem, you don't start from zero, right? Your first thought is, have I ever seen something like this before? And then you adapt to what worked in the past. And this is basically how it works for us. Something happens, and our brain just files it away as a memory. If something we tried worked well, that memory gets a little stronger, making it easier to find later. Then, when a new challenge pops up, our brain instantly scans that mental library for similar situations to give us a starting point. Memento is designed to give that exact same superpower to an AI. So, how does this all work under the hood? Well, it's actually surprisingly simple. It really boils down to three core parts. First up, you have the planner. This is the strategist. It gets a new goal, and the first thing it does is consult the memory, asking, what's the closest thing to this I've ever done before? Then it uses that past experience to break the new problem down into a series of smaller, manageable steps. Next, you have the executor. This is the doer. It just takes the plan, one step at a time, and gets it done, using whatever tools it has, like searching the web or writing a bit of code. And finally, you have the heart of the whole system, the case bank. This is that perfect memory we were talking about. It's a library that is constantly growing, storing every single thing the agent has ever tried. All right, the theory sounds fantastic. A planner, an executor, and a perfect memory. But here's the real moment of truth. Does this clever idea actually perform better in the real world? Let's take a look at the data. Okay, first up is the GAIA benchmark. This thing is basically a brutal obstacle course for AI, designed to test them on really complex, long-range tasks. And the results? Well, they speak for themselves. Memento clears the bar with almost an 88% success rate. That doesn't just beat the average, it puts Memento at the very top of the leaderboard. And it wasn't a fluke. They tested it on the DeepResearcher benchmark, which is all about doing complex web research in real time. Here, Memento scored a 66.6%. Now, all you need to know about that score is that it's a measure of accuracy. And what's really important is that it outperformed even the state-of-the-art systems that still rely on that super expensive retraining process. But for me, this is the real test of intelligence. What happens when you throw the AI a total curveball, a problem it's never ever seen before? In theory, this is exactly where a memory-based system should just clean up. And yup, the data backs it up. On a dataset designed to be completely new and different,
Memento saw its performance jump by a full 8%. They tried again on another dataset of tricky, novel problems. The result was even more impressive, a performance boost of nearly 10%.
And even on a third one, still a solid 5.5% improvement. The pattern here is unmistakable. When faced with the unknown, having a rich library of past experiences to draw on gives Memento a huge, measurable advantage.
And this chart is awesome because it shows us exactly why it's so powerful. It's like building with Legos. You start with just the base LLM, and you get a score of around 49%. Now, funny enough, on this specific test, just adding live tools actually made things a bit worse. But then, look what happens. You add the planner, the strategist, and the score shoots up to nearly 60%. And then for the final piece, you add the case memory. That's the secret sauce, and that's what gets you all the way up to that winning 66.6%. Each component adds a crucial layer of power.
So, what does all this mean for the future? Let's zoom out a little and think about the big picture here. So, why does this matter so much? Well, for 3 big reasons. First, it makes AI agents way more efficient. No more burning through mountains of cache and time on retraining. Second, it makes them way more adaptable. They can learn as they go from new experiences in real time. And third, all of that makes them more scalable. This gives us a real, practical path forward for building the kind of general-purpose AI agents that get smarter over time, just like we do. The researchers themselves said it best. This is a step towards open-ended skill acquisition. That phrase is so important. It's not just about solving today's problems a little bit better. It's about building agents that can learn to solve any problem that tomorrow throws at them. It's a fundamental shift from an AI that is trained to an AI that can truly learn. It really makes you think, doesn't it? If you had an AI with a perfect memory, what would be the first skill you'd want it to learn for you?